Hey, hello to all. In this video, we are going to discuss one of the DMSO base oxidation reaction, that is in Swan oxidation. The Swan oxidation is named after its discoverer, that is a Daniel Swan. The basic role of this name reaction is to convert the primary or a secondary alcohol to respective aldehyde and ketone. The reagent which is used in this reaction is an DMSO, that is a dimethyl sulfoxide. You can see here the structure of the DMSO look like this, that is a dimethyl groups are present over here and the sulfoxide group in the center, that is a dimethyl sulfoxide, the reagent which is used in this reaction. The DMSO itself doesn't act as an oxidant, but it need an activator like an oxyl chloride and the base that is a basic medium. This is what a reagent which are used in the Swan oxidation look like, that is a DMSO plus oxyl chloride and base. Now what is the reaction scheme over here? That is, it basically converts primary or a secondary alcohol in the presence of the dimethyl sulfoxide, oxyl chloride and the basic medium in the aldehyde or ketone respectively. How does this general reaction scheme, if we see the general reaction scheme over here, this is a kind of the primary alcohol. By using the DMSO, oxyl chloride in the basic medium, it is get converted to the aldehyde respectively. Now let us see the mechanism of this reaction, that is how this reaction. So now let us see the mechanism of the above conversion of the primary alcohol to the respective aldehyde. What is the first step in this mechanism is that is a formation of the chlorodimethyl sulfonium chloride. Now the question is that how this chlorodimethyl sulfonium chloride is formed. We know the reagent used in this reactions are DMSO and the oxyl chloride. In the first step, what will happen over here, that this DMSO will react with the oxyl chloride. How? Let us see. This is a dimethyl sulfoxide and its reaction with the oxyl chloride. Cl, C double bond O, then C double bond O, Cl. Now what will happen over here? That this oxygen is more electronegative. The electrons from the sulfur will shift over here. After shifting of the electron, it will convert into O negative. After that, this will attack over this carbonyl carbon and this will shift over here. Now how does the product look like? You can see over here, this sulfur will remain as it is, as the bonding pair from sulfur shift towards the oxygen. So sulfur will carry the positive charge. Here there will be the CH3, then this will be the CH3. Then what will be the next step? That C, then this electrons are shift over here, so O negative, then Cl, then this group will remain as it is. Now in the next step, what will happen over here, that this will neutralize itself and this Cl will be free. Now how does the reaction look like? This sulfur will remain as it is, then here there will be the dimethyl group, then this oxygen, C double bond O, C double bond O, Cl. Now you know that in any kind of the reaction, if there is a chance to remove the gas, that is if any gaseous molecule is removing from the reaction, is the driving force of that reaction. So here we can remove the CO2 and the CO gas. So how does the structure will look like? That this electron will shift over here. After that shifting, this bond will shift over here. While neutralizing that bond, this CO will be free over here and this Cl will also free. As this Cl will free, it will come towards our sulfur molecule. Now how does there will be the elimination of the one molecule of CO2 and one molecule of CO. Now how does our structure will look like? This will be sulfur plus CH3 and one of the Cl will attach over here, and initially in the system one of the Cl was present as a Cl minus, so this Cl minus will present as it is, and this is known as the chlorodimethyl sulfonium chloride. Now our reagent, that is an DMSO, is get activated by using the oxyl chloride. Now after that, this is our the main reagent, which is now in the second step we will use this reagent to, now we will move for the second step, that is a second step is attacked, that is this chlorodimethyl sulfonium chloride, this chlorodimethyl sulfonium chloride will, this chlorodimethyl sulfonium chloride will react with alcohol, will react with our alcohol molecule, react with alcohol. Now what will be the next step over here? You can see, we will take our alcohol moiety, that is this is our primary alcohol RCH2OH, then this is chlorodimethyl sulfonium chloride positive, and then here there will be the Cl, this is chlorodimethyl sulfonium chloride. Oxygen carries a lone pair of electron. What will be the first step? This lone pair of electron will shift over here. After the shifting, this Cl will be free. Now how does the structure will look like? The structure will look like this. You can see here how does this structure look like. R CH2 will remain as it is. This OH, as oxygen donates its lone pair of electron, it will carry the positive charge, then sulfur and then dimethyl. Okay, sulfur and then dimethyl. Here there will be the positive charge. To neutralize this H plus will be free over here. Then how does the structure will look like? R CH2 O S CH3 CH3. As we know, in the system our base is present, that is triethylamine, the base is present. What is the role of the base? To abstract the acidic proton. What will be the base do over here? That is, we will take our base, that is Et3N. It will abstract the acidic proton from here, that is the proton which is attached to the methyl group. Now how will the structure will look like? Structure will look like this: R CH2 O, then sulfur, then CH2. As the proton is get abstracted, so here there will be the minus sign, then CH3, negative sign, then here there will be the CH3. Now what will be the next step is that this will abstract the proton from here, that is this will take this proton from here, then as a H plus. Then how does the structure will look like? You can see over here, R CH minus, then O CH3 CH3. Okay, then this negative charge will restored over here, that is oxygen is electronegative, so it will attract the electron which are present on adjacent CH, and then this group will be free. This group will be free as the, this group will be free. You can see here, initially here is the formation of double bond OH, that is our required product is aldehyde, and the side product will be SCH3 CH3. It is known as DMS, that is dimethyl sulfide will be our side product. This is how the mechanism of the Swan oxidation occur. Now after seeing the mechanism, you can see in this step the base is playing a very important role in the formation of the aldehyde. You can clearly see that. But what if the base is not present? If the base is not present, then simply the DMSO with oxyl chloride gives a reaction known as a substitution reaction instead of doing the oxidation of the following alcohol. Now how does the mechanism look like if the base doesn't present? What we will do, we will take this substrate as it is, which was formed before the base. We can write it as RCH2. Before using the base, we get the substrate as like this. Now we know that when this kind of the substrate is present, we will do further the action of the base. But what if the base is not present? We will follow this step, that initially the Cl molecule which was left, which was removed, will act as a nucleophile over this, and this group will be free from here. Simple substitution will occur and we will get our product as RCH2Cl. This is a substituted product by substituting the alcohol by Cl molecule. This is how the reaction look like in the absence of the base. So these are the two kinds of the mechanism by using the DMSO based reagent, that is in Swan oxidation. That is, I can generalize all this reaction. CH2OH if on arrow DMSO COCl2 and ET3N is ET3, and that is a triethylamine base is mentioned, then the product which we get, it will be aldehyde. And if on the arrow same reactant over there, only DMSO and oxyl chloride is given, then product will be substituted product. This is how the base play an important role in the Swan oxidation reaction. After this, we will see some sort of the example by using this reagent. Let us look towards this first example, that we can see here clearly the DMSO oxyl chloride when a basic medium is given. That means this is a Swan oxidation, and this alcohol which is mentioned over here is the primary alcohol. Then what will be the product over here? That is, we will get the aldehyde as our product in the place of the oxidation will occur of primary alcohol to the aldehyde. Now see the next example. Here again the alcohol which is given, this is the primary alcohol, the reagents are same. The product which we get in this reaction is the aldehyde, that is primary alcohol to the aldehyde. The oxidation will occur. In the second example, you can see similarly, here there is also the presence of the primary alcohol. Then what will be the product? Here in the place of the primary alcohol, you will get the aldehyde as your product. Beside this, we will see one of the example of the substitution reaction, that is, if this kind of the molecule is given and on the arrow only COCl2 and DMSO is mentioned. In absence of base, what will happen over here? Yeah, you learn it that here there will be the substitution occur, that this OH will substituted by the Cl molecule. This is how the product look like. So, well, this was all about the Swan oxidation. Hope you understand each and every point. Any doubt, you can post it your doubt in comment section. Thanks for watching this.